Our next lesson is going to be solving for variables within a formula. And this can get a little tricky, but we've already done that. In the example we saw in the previous video, we said PV is nRT, and our goal was to solve for V. So to do that, we need to do a little bit of algebra. So we're going to isolate V, and we will divide both sides of that equation by P. So if we divide the left side by P and divide the right side by P, the result that we get is V equals nRT over P. We have indeed solved for that variable. But we could have solved for any of those variables. For example, we could solve for T if I have PV equals nRT. If my goal this time is to solve for T, then I have to decide, how do I get T by itself? Right now T is multiplying n and r, so I would divide both sides by n and r. Divide the right side by nr, divide the left side by nr, and then you'll notice those cancel on the right side, so I get T equals PV over nr. And I know most people don't particularly like algebra, but algebra does save a lot of time, because with one formula, with PV equals nRT, we can indeed identify any of those 5 variables by using algebra. But that one was relatively easy. I'm going to take a look at the examples that are in the student supplement to get us a feel for how this is going to behave. So the first example I have here is the equation I'm given is P equals Fs over T. And I am asked to solve for S. So you have to get S isolated. Now you'll notice there is a T in the denominator, and that is dividing the S. So the first thing I'm going to do is I'm going to multiply both sides by T. Multiply the left side by T, multiply the right side by T. When T multiplies the right side, the T's cancel, and I'm left with TP equals Fs. Now our goal was to solve for S, so at which point I can go ahead and divide both sides by F, and I can say TP divided by F equals S. Now I could have done that for any one of the 4 variables in that problem, although P is already solved for, but F, S, and T could have been isolated to give us equations to identify those variables. Now the next example from the student supplement is a little more challenging. We have B equals 1/2 7a plus c. And the goal here is to solve for a. So looking at this, we notice that there is a 1/2 that is on the right side. Now we can multiply both sides by the reciprocal of 1/2, which is 2. So I'll multiply the left-hand side by 2. That'll give me 2b. Multiply the right-hand side by 2. That will be 2 times 1/2 times 7a plus c. So you'll see 2b on the left-hand side. On the right-hand side, 2 times 1/2 is just 1 times 7a plus c. So we get 2b is 7a plus c. Right. Looks like my a has turned into a capital A, so I probably should go back and change that and make it a lowercase a. We want to solve for that lowercase a, so let's subtract c from both sides. 2b minus c on the left-hand side. 7a plus c minus c is going to give me 7a. So again, we have 2b minus c equals 7a. And then we're going to want to divide both sides by 7 to get a by itself. So we finish with 2b minus c over 7 equals a as our solution. Now the next one's a bit of a challenge. We have P equals a times 1 over b plus 1 over c. And our goal here is to solve for b. So again, I may take a slightly different approach than the student supplement, but I want to figure out a way to get b by itself. The first thing I'm going to do is I'm going to go ahead and multiply the a answer. We're going to distribute a times 1 over b, a times 1 over c. So we'll take p is a over b plus a over c. Now, I want to get b by itself, and you'll notice that I have b in the denominator, and that's what makes this very challenging. So my next move, I'm going to multiply both sides by the least common denominator. And we usually abbreviate that by LCD. And what is the LCD in this case? In this case, the LCD is BC. The denominator is b, the denominator is c. b times c will give me the least common denominator. So I'm multiplying the left-hand side by BC, and I'm multiplying the right-hand side by BC. So I'll get BC times P, multiplying on the left side, BC times A over B plus A over C. And again, our goal is to solve for B. Let's keep that in mind. Continuing, BCP equals BCA over B when I distribute this way, BCA over B plus BCA over C. Now you'll notice we get some cancellation here. So our next line will be BCP equals, the B's go away, CA, well let's write it in alphabetical order as AC, plus, on this side, the C's cancel, BA, again let's write it in alphabetical order as AB. So remember our goal is to solve for B, but I have B's on both sides of the equation. When that happens, I'm going to subtract AB from both sides. Subtract AB from the right. Subtract AB from the left. So we're going to get all the B's on one side. Get all B's on one side of the equation. That's going to be a good idea for us. Where's that going to leave us? BCP minus AB equals AC plus AB minus AB is just AC. Well, the next move is to recognize I have B's in both places. I want to divide out a B. I want to factor out a B. If I factor out a B, I am left with what? Notice B times CP would give me BCP. I factored a B out of that one. B times A would give me AB. So factoring, in essence, is the reverse property of the distributive property, equals AC. And we're just about finished. Our goal is to solve for B. All I've got to do is divide both sides by CP minus A. And I get what? I get B equals AC over CP minus A. This is a challenging idea, so let me go ahead and give you another problem that is similar to that one. If I have 1 over A equals 2 over B plus 3 over C, and this time I want to solve for C. The first step is to multiply both sides by the least common denominator, and the least common denominator in this case is ABC. So I multiply the first guy by ABC, so ABC times 1 over A equals ABC times 2 over B plus 3 over C. When I distribute this, I get ABC over A equals 2ABC over B plus 3ABC over C. So the A's would cancel here, so we get BC. The B's cancel here, equals 2AC. The C's cancel here, plus 3AB. Now again, we're solving for C. We've got to get all of the C's on one side. So I'm going to subtract 2AC from this side, subtract 2AC from that side. So that gives me BC minus 2AC equals 3AB. And we want to solve for c, so the next move is to factor the c. If I factor c, I am left with b minus 2a equals 3ab. Then we're going to divide both sides by b minus 2a. To conclude that c equals 3ab over b minus 2a. And let me finish with the last example that is in the student supplement. If I have y equals 2/3 times x minus 5, and my goal is to solve for x, first thing I would do, I would recognize that 2/3 is multiplying x minus 5. So I'm not feeling real good about that. I have a couple options. I could distribute, or I could multiply by 3/2. I think maybe I'll distribute. So let's distribute this way to say y equals 2/3 x, 2x over 3, minus 2 times 5 is 10 over 3. At this point, I would multiply both sides by the LCD like we did in the last example. And the LCD in this case is 3. So we're going to take 3 times y equals 3 times 2x over 3 minus 10 over 3. So my next line will give me 3y equals 3 over 1 times 2x over 3 minus 3 over 1 times 10 over 3. Doing the fraction multiplication gives us 3y equals 3's cancel here, 2x minus 3's cancel here, 10 over 1, which is 10. We still want to solve for x. We want to get everything away from x. Let's deal with the minus 10 first. So we'll add 10 to both sides. So I have 3y plus 10 equals 2x. Then I'm going to divide both sides by 2 to solve for x. And we'll say 3y plus 10 over 2 is x. And if we wanted to, we actually could break this up into two fractions. I'm not sure this is any better, but we could say 3y over 2 plus 10 over 2 is x, which would be the same thing as saying 3y over 2 plus 5 is x. But frankly, I prefer this one. So this is a challenging lesson. I encourage you to try all of those problems again that I did in the lesson and see if you're able to complete that.